Okay, now we're moving into the second main focus of the first unit. In Lesson 8, we're going to work specifically into powers and how we can take this abstract concept of a power and understand what it means in terms of a real-life geometric representation. So we do have some really important vocabulary to go through, and then we're going to practice our geometric representations. This is a skill that you will be called upon to demonstrate on assessments, so you should be familiar with it. So let's start with the vocabulary. So the very first thing we need to talk about is, what is an algebraic term? An algebraic term is basically any combination of multiplication and division of variables and coefficients separated by addition and subtraction signs. So if you have an equation, let's write an equation. We'll say we've got 3x squared plus 2x plus 5. Okay? This equation, or in this case, it's an expression. It doesn't have an equal sign, so it's an expression. This expression has 3 terms, okay? This is term 1. This is term 2. That's term 3. So an algebraic term is a combination of coefficients and variables. And anything within there that's multiplication and division counts as part of the term. And when you reach the addition and subtraction sign, that's where the term ends. All right? So, what is a coefficient and what is a variable? These are words that I've been using to describe a term, so let's talk about those. So a variable, we're going to skip to variable, is a symbol representing a value that is unknown or changeable. That's what variable means. Vary means to change. So we'll say changeable. X, Y, theta. They're all symbols representing a variable. The ones that we use most commonly are letters, but we can use the Greek letters. We could use stars, dots, anything really that's representing a value that is unknown and or changeable. So again, most of the time we're going to be using letters to represent that. A coefficient is a number that modifies a variable. Okay, by modify, I mean we're talking multiplies or divides, but a lot of times it's multiplication. So let's say we have 3x. Okay, this 3 is the coefficient. It's modifying our variable. If it was 1 over 3x, that would be x multiplied by 1 over 3 or x divided by 3. They're the same thing. So everything really boils down to multiplication when it comes to coefficients. So a coefficient is a value, okay, a number that is modifying the variable. So instead of the variable just being x, we have one of them, it's 1x. Now we have 3x, so it's 3 multiplied by x. Do you know what we call a number on its own that has no variable? Like this plus 5 that we have there. That's called a constant. And a constant doesn't change. That plus 5 isn't changing. It doesn't matter what number x is. It doesn't change. So it's constant. Okay? So these are really important pieces of terminology that we're going to use, especially as we forge ahead in our number manipulation and introduction to algebra. So what is the exponent? The exponent we know is I want that in blue. The exponent tells us how many times we multiply the base. So x to the exponent 2 tells us it's x times x, okay? And the degree of a term, this is really important. The degree of a term is the sum. Now, what does sum mean? Sum is an addition word, so we're adding. So it's the sum of all the exponents in a term. Okay, so we've now covered our really important vocabulary, and let's put it to use. I'm going to shrink this down just a little bit. All right, so we've got a bunch of terms. We're going to kind of identify the different pieces, and we're going to talk about what they mean. So the coefficient of this first term, the first term here, 2x. The coefficient is 2. Okay, that's what is modifying x. The variable is x. What is the power of that variable? What is the exponent of that variable? The exponent of that variable is secretly 1, okay? So in here, when you don't see an exponent, you can pretend that you have an exponent of 1 because that's just x on its own. How many times is it multiplied? Well, it's 1. It's 1x. So there's only one of them. So the power of the variable here is 1. And if we add all the powers together, add all the exponents together, there's 1, and it's 1, we get the degree of 1. So let's look at this one. The coefficient here is -3. The variable is y. The power of that variable is 2, so the degree is 2. The coefficient in this one is 2. We have variables x and y. And the power of the variables are 2 and 1. Remember here we have that secret 1. We're going to add this together and the degree is going to be 3. In our last example, coefficient's 3. We have x, y, and z as our variables. Each of those variables has a exponent of 1. So I've got 1, 1, 1. And I'm going to have a degree of 3. And what does the degree matter? Well, the degree is actually an interesting concept. It can tell us a lot about a term. It tells us a lot about a term. And when we get into Unit 2 in our linear relations, the degree is going to be one of the major clues that we're going to use to determine if a relation is linear or not. But right now, we're going to look at what that degree means in terms of a more concrete, real-world idea. So if we're going to represent these geometrically, we're going to represent them in more of a concrete fashion. And we're going to bring in some geometry and measurement, that's Unit 4. We're going to bring in some geometry and measurement ideas to help us. And so we're going to think about what is a line, what is an area, and what is a volume. So these are all things that you've calculated before, but maybe you haven't thought about how they can be translated into something abstract like an algebraic term. So degree 1, for example, 2x, this is a length, okay? So degree 1 is a length. This is a length. It's 2x long. Now remember when we're multiplying, multiplication is repeated addition. So you could secretly say that this line is exactly 2 x's. I've added them together. I've made one line. It's a length of 2x. So let's think about what happens when we go to a degree of 2. So degree of 2, so let's say we have x and y. Degree of 2 can be represented as an area. two dimensions, really. Because when we multiply an area together, so let's say if x was 2 and y was 3, I made a rectangle, and this is 2, this is 3, and the area is 6. I multiply them together. So I could say that this area is x by y, right? I'm using that area to represent that. Let's go to degree 3. Degree 3 can be represented as a volume. So let's say 8y cubed. 8y cubed. I'm representing this as a volume, so 3 dimensions, like that. Okay. And I want to take this and split this up. So what I've got here, I'm going to have y times y times y. Y times y times y is 3 cubed. Technical problem averted. Y times y times y gives us y cubed. But what about the 8? How do I deal with the 8? So I could put the 8 at the front. Say it's 8y times y times y is y cubed. Or I could say 8 is actually a cube itself and go 2y times 2y times 2y. Like this, 2y by 2y by 2y, and the volume is going to be 8y cubed. Because that's how a volume is. You multiply the length by the width by the height, and you get your volume. And we're going to practice this kind of thing tomorrow in class quite a bit.